motet composed by Johann Sebastian Bach and first performed in 1736, calls for a Lituus, a very long trumpet-like instrument. Today there are no original surviving examples of the Lituus. However, research funded by the Engineering and Physical Sciences Research Council and carried out at the University of Edinburgh has led to Bach's forgotten horn being recreated and used in an experimental performance in Switzerland earlier this year. The research work was supervised by Professor Murray Campbell, who explains more about the background to the project.
From my point of view, the story actually starts with an email out of the blue from a gentleman called Mike Duprose, currently working at the Schola Cantorum in Basel. This is Europe's leading music conservatory specialising in early music. The Lituus was specified by Bach for one particular piece of music, a cantata or motet called O Jesu Christ, mein Lebenslicht. The versions which have just been made in Basel are very light wood, several metres long, and end up in a fairly small bell. It's been known as Bach's forgotten horn because Bach specified this in this particular cantata, but nobody knows what he meant. There are no instruments known to have been around in Leipzig in Bach's time which were called Lituuses. No Lituus players appear on any rolls of musicians. No one knows what exactly he meant.
So how do you go about recreating an instrument that no one alive today has touched, heard or played? The EPSRC funded PhD student who worked on the project was Dr Alistair Braden. He developed the computer modelling or optimisation software that led to the recreation of the instrument. Two other EPSRC funded PhD students at Edinburgh helped in the recreation work using Alistair's software. Alistair describes the information he had to work with.
Well, we were given some indication of how they expected it to play. Some of the sort of the musical descriptions, like say tone quality and what notes it was expected to be playing, and so on. They sent us cross sections of instruments that they believed to be similar. So we had this as the starting point, and we were given some indication of what shape it is. Like for example, if you imagine a modern trumpet, it's curved round on itself. Whereas the Lituus, the instrument that we were asked to design, is completely straight. There are no curves in it at all. And so they gave us what for them was their best educated guess as to what shape they thought it was.
So Alistair's computer modelling work set out the design of Bach's forgotten horn so it could be made up into a working musical instrument. Alistair describes how his work builds on computer modelling systems that are already available, but the difference is that his optimisation software gives unprecedented precision.
Optimisation software is essentially a computerised tool for instrument manufacturers and designers. It allows them to try out new designs without the expense of building them, and it allows them to solve problems either with their existing instruments, like say for example, I've got this trombone in front of me and I really like it, apart from this one note which is a bit out of tune or it doesn't respond in the way that the other ones do. So the manufacturers would then be able to use the optimization software to adjust this one feature of the instrument that they don't like, while keeping all the features of the instrument that they do like the same, as much as this is possible. So the optimizer can be used to take these rough ideas, these fragmentary historical information that we've got, and turn them into usable instruments. Some of the past attempts done before I started work on this were able to give instrument shapes which, in theory, would have desired properties. But the real difficulty with them was that you would get these quite sort of jagged shapes. So what my technique does that's new, particularly, is the ability to optimize and design plausible instrument shapes reliably. So we can be sure that when we have designed an instrument using this optimizer, what we're going to get out of it is going to look like a brass instrument. It's going to have the right kind of smoothly flaring bell shape that we're all familiar with. And so you could hand this blueprint to a manufacturer and he'll immediately be able to build it.
In the long term, the potential uses of the research go much further than work with musical instruments, as Murray Campbell explains.
We have also had collaborations with firms like Rolls-Royce and other firms who are actually interested in the study of commercial ducts and cooling tubes in equipment and so on, which are not necessarily easily accessible for measurement and which are therefore particularly useful for non-invasive acoustic measurements. That's got a lot of industrial applications, of course, for looking at tubing which is relatively inaccessible, but for which a leak could be catastrophic.
We can only speculate as to why the Lituus didn't survive as an instrument. Perhaps its cumbersome size had something to do with it. After all, being extremely long and built in one long section, it's not something you can pop into a rucksack and take along to music practice. The extracts we've played from the experimental performance that took place earlier this year also show it's rather difficult to play. So, apart from the historical significance of the work to recreate the instrument, Alistair explains what the future could hold for his research.
The ultimate dream, if you like, is to have marketable instruments, and instruments on the market, indeed, that have been developed with the assistance of the software. Ultimately, it would be the manufacturers who design the instrument, but the optimization would be a tool that helped them. In the same way as, say, a chisel is the tool that helped Michelangelo to build David. You wouldn't say that David was chisel approved, if you like, but the chisel was very useful to Michelangelo to get the shape of David out of the marble. And the idea of the optimizer is to be, if you like, a chisel for the designers, for the manufacturers, to make it easier for them to get the shapes and the sounds that they want out of their instruments.